The point of this question is to end up using the information that we gain in parts A, B and C to sketch the graph of what could be considered quite a horrible log function. We probably don't know off the top of our heads what it looks like, but let's have a crack. So we're going to start off to find the derivative. Now here we should start getting used to the idea that this is a product rule question. So this is a product. So that's meant to be a letter A, not that anyone would believe me. So let's try again and write the letter A. That's much better. So f of x equals u times v, where u equals x and v equals log of x. So therefore, du dx equals 1 and dv dx equals 1 over x. So if we're going to use the product rule, then we're going to say dy dx equals u dv dx plus v du dx. And now let's chuck some stuff in there, which equals x times dv dx times 1 over x plus v log x times du dx, which is 1. When I cancel these out, the x's, I'll end up getting 1 plus log x. And I've written ln there because it's log to the base e, and this is the natural log, so that's fine. So therefore, I'll answer the question the way it's asked. I'm given it as f of x, so I'm going to answer of f dashed of x. And there is my answer. Now I've just stored my answer away here for future reference, and I'll go on to part B. When f of x equals 0, so this is asking when x log e x equals 0. So it's really asking for a x-intercept. So here we go. This means that we need to have a think about what x is allowed to be and what x isn't allowed to be. And that's given to us up here. So keep this in mind, that x must be greater than 0. So I can't simply say that if x is 0, then this will be 0. But I can say that either x equals 0 or log of x equals 0. Now, this will be rejected because it's outside the domain that's acceptable. And of course, what makes that domain is this log x. But here, log of x equals 0. If log of x equals 0, so this is a bit like doing our null factor law. Either this or this equals 0. Either this or this equals 0. If log of x equals 0, x equals 1. So therefore, f of 1 equals 0. And I'll write that down here for future reference as well. Next, I'm going to do part C. I need to solve this equation to set it to 0. So I'll say, therefore, 0 equals 1 plus log of x. So therefore, negative 1 equals log of x. And therefore, we're going to take the exponential on both sides. So x is e to the negative 1. So finally it comes to sketch this graph, and we need to put a few of these things into mind. So first of all, we can see here that this has an x-intercept of 1. So if I'm going to draw the graph, and here we go, knowing that x is greater than 0, I don't have to spend much time over this side of the graph. So here's my graph. Now, this is going to be a typical sort of a log graph. So it looks like I'll be starting somewhere here. So let's draw a rough idea. The log graph looks something like that. Now remember, as I get very close to 0, this x will be multiplying a number here. So this will get very, very close to 0. So it's actually going to start, it doesn't exist at 0, remember, but 0 times any number will be 0. So as soon as this log starts happening, the very, very smallest number will be really close to 0. Then this is going to go down and turn around until having an intercept at x equals 1. So it'll intercept at x equals 1, and then it will continue to take this sort of a shape. So we'll build it up and it'll probably look something like that. So here is my intercept at 1, 0, and then here's my turning point, which is at e to the negative 1, and I don't know what. So I better work this out. If f of x equals x log of x, and x is e to the negative 1, then that'll be e to the negative 1 times log e to the negative 1, which equals e to the negative 1 times negative 1, which is negative 1 over e, or negative e to the negative 1. This is good that we've got this negative sign because we are under the x-axis, so that's pretty handy. So I'm going to write that as e to the negative 1, or I could have written it as 1 over e, that should be negative, and then negative 1 over e. And there's my turning point.
If you found this video helpful, please subscribe or like. Thanks.